So our aim for today is to, first of all, know what a parametric equation is, and then, of course, learn how to differentiate them. So, kicking off with what they are, I've written here parametric equations are those where x and y are related indirectly, which might not make that much sense, but when I show an example, hopefully it will. So it's through a third parameter, which we will call t. Usually, they might use a different one. So for example, they might tell you that x is equal to 2t plus 9, and that y is equal to 2 squared, or something along those lines. Okay, and so that's called a parametric equation, and it is possible to join those together to make a Cartesian equation, which is what a normal x and y one is called. But we don't have to do that in order to correctly differentiate them. And we're just going to be using the power of the chain rule to do it. So you will see over on this side, we have got two parametric equations. And our first aim is to find dy by dx in terms of t, and then we're going to have a go at doing the tangent. So we're going to have a go at x equals t squared first. So when we differentiate, I know you guys are probably like, right, we've got y equals, I don't know, 3x squared, and we differentiate that and we get 6x. And maybe you don't pay that much attention to what is on the left-hand side. But when we've done that, we've differentiated y with respect to x. So with this one, we're differentiating x with respect to t, which means that it's 2t. Okay, so whatever the subject is goes on top, whatever is not the subject goes on the bottom. So if we then look at what y is equal to 5 minus 2t. And when we differentiate that, we'll do dy over dt, and that will equal negative 2. And if we just think about the chain rule for a moment, dy by dx, if we want to get dy by dx, you're always going to have dy on the top and dx on the bottom, and hopefully another parameter which is the same on either side, okay, which makes dt cancel out. So therefore, dy by dx is going to equal dy by dt, which is our negative 2, multiplied by dt by dx. So this one is the opposite. So when we switch it over, we're going to be timesing by 1 over 2t. And those cancel out, so we get negative 1 over t. Okay, I think on the formula sheet, it may have it written as dy by dx equals dy over dt divided by dx by dt, which is exactly the same, obviously, as timesing by dt by dx, but hopefully that makes the same sort of sense. Okay, so that is the gradients. The gradient is in terms of t. So if we want to find the equation of the tangent where the point is t equals 2, it's too many 2's and too many t's, then we need to, first of all, find the gradient. So let's find the gradient at that point. So gradient at t equals 2 would be negative 1/2, just substituting 2 in here. And then if we want to find out a point to help us find the equation, we will put t equals 2 into this one and this one. So when we put 2 in here, 2 squared is 4. And when we put 2 in here, we've got 5 minus 4, so 1. And now we can just chuck it straight into our equation of a line formula. Y minus y1 equals the gradient x minus x1. And then you can make that pretty to tidy it up. So negative 1/2 x plus 2, which means it's y equals negative 1/2 x plus 3. And that is how we do parametric equations.